Hello everyone, welcome back to my channel Love Pharmacy. So if you are watching this channel for the first time, make sure to subscribe and please like the video, and it would be useful for me and for other also. And today's topic is glycolysis. Okay, so all we know glycolysis maximum, but this video gives you brief information about the enzymes which are involved and how many types of glycolysis takes place. So the video continues. Let's start. Glycolysis means breakdown of glucose by enzymes releasing energy and pyruvic acid. So remember, generally our body needs energy, right, to perform some activities or whatever it might be. So the glycolysis, what's the activity of glycolysis means? It breaks down glucose. Where we get energy? We get energy from glucose. So I have already told you that every breakdown of a molecule needs some enzymes. So that glucose is breakdown by enzymes, and when it breaks down, it produces energy and as well as pyruvic acid. I have already told you, when we take food, we get energy in the form of pyruvic acid, right? So before getting the pyruvic acid, so this is the process which takes place in our body. And glycolysis generally occurs in the cytoplasm. And glycolysis is of two types. One is aerobic glycolysis and second one is anaerobic glycolysis. So itself clear that what is aerobic and anaerobic. So aerobic means the process which takes the oxygen, and anaerobic means the process which occurs in the absence of oxygen, right? So generally glycolysis, as we know, is only aerobic, but in anaerobic conditions also the glycolysis takes place. So we can first of all see what is the structure of pyruvic. In the previous video, that citric acid starts from the pyruvic acid, right? So here the pyruvic acid is a 3-carbon compound, but the glucose is a 6-membered compound, right? Here aerobic glycolysis, pyruvate is the end product of glycolysis. Generally we know pyruvic is the end product of glycolysis, but the starting material is glucose. When pyruvate enters into TCA cycle, it undergoes oxidative phosphorylation leading to production of 32 ATPs. By this we get energy. Here see, pyruvate when entered into TCA cycle, there undergoes phosphorylation. So that phosphorylation which produces the energy, that is completely in the presence of oxygen. So it is an aerobic and it occurs in our body. And another type of glycolysis is anaerobic. So anaerobic means I have already told you, absence of oxygen, right? So the pyruvate is get converting into the lactate by using the anaerobic glycolysis. So how means, when we do a lots of vigorous exercises, or it might be the jogging, so our breathing levels are low, right? So at that time the lactic acid is produced by the muscles. So because of that reason, we are unable to breathe properly because of low amount of oxygen supplement, right? So that is the condition of anaerobic glycolysis. In both conditions we are getting energy, but the process of getting energy is dependent on oxygen for the glycolysis and independent of oxygen for the anaerobic glycolysis. So the point is clear with myself, that aerobic and anaerobic glycolysis. And now, where do the glycolysis occurs? The location of glycolysis occurs in the cytoplasm, that is to get the energy. And here I have already told, glucose is a 6-membered molecule. It is converted into the 3-carbon compounds of pyruvate. So see, here we are getting 2 pyruvates. So what are the end products of glycolysis means 2 pyruvates are the end products of glycolysis. So why I have written 2 means, see, 2 pyruvates we are getting, and that 2 pyruvates also the 3-membered carbon compound. So that's why I have written 2 pyruvates of 3-membered carbon. Okay, and uses, you know, I have already told energy production, right? And some more uses, like in hepatocytes, we already know what is hepato, that is liver. Cytes means obviously the cells. So glycolysis is involved in the control of hepatic glucose production. Generally, what my point is, the liver helps in the control of excessive glucose production. Okay, so see here, the liver helps in the control of excessive production of glucose, so by the process of glycolysis. Okay, and stimulate glycolysis. So generally, you know that what is diabetes mellitus, right? So diabetes mellitus means condition that is the chronic metabolism that where the excessive glucose levels are there in our blood, that is hyperglycemia. We already know hyperglycemia, which is nothing but the excessive amount of blood glucose levels, right? So when the glucose levels are more, so what we have to do, there is two conditions. Either the pancreas should release the insulin to control the action of glucose, or the another condition is whatever the glucose is produced in the blood should be controlled. So the glucose, generally we all know that it is stored as glycogen, right? So it should get converted into the glycogen, that is excessive fat. So that is the process where the liver is doing in our body. Okay, and glycolysis is also called as EMP pathway. So why we call this as EMP pathway means this was discovered by Emden, Meyerhoff and Parnas. Okay, so that's why they don't ask you directly write the glycolysis pathway. If they ask glycolysis, it's good. But when they not ask the process of glycolysis, just remember they also may ask what is the EMP pathway. So try to remember EMP pathway, and the precursor molecule, the initiative step, the initiative product is the glucose, and the final products are the two pyruvates. Okay, so now, so the process starts from here, that is the glycolysis. So that is glucose by using the glucokinase enzyme, it's going to convert into the glucose 6 phosphate, and by using the phosphoglucose isomerase, it get converted into the fructose 6 phosphate, and by using the phosphofructokinase, it is get converted into the fructose 1,6 bisphosphate. And here just we have to wait. So after completion of 4 products, 4 intermediates, we should stop here, because fructose 1,6 bisphosphate have the capacity to generate 2 products that are DHAP. We call it as dihydroxyacetone phosphate, and the second one is the glyceraldehyde 3-phosphate. So these two are fructose 1,6 bisphosphate by using the aldose enzyme. Okay, so they may ask what is the product that is produced, what is the intermediate metabolite that is going to produce the 2 compounds, that is the 2 intermediate metabolites in the glycolysis. So you should say that is fructose 1,6 bisphosphate. By using the aldose enzyme, it's get converted to DHAP and glyceraldehyde 3-phosphate. And again, one more thing, here DHAP is again have the capacity to convert into the glyceraldehyde 3-phosphate by using the triose phosphate isomerase. Okay, so here glyceraldehyde 3-phosphate is get converted to the 1,3 bisphosphoglycerate, and by using the glycerate 3-phosphate, here enzymes are easy to remember. When you are so clear to remember the products, that is the metabolites, then it is easy to remember the enzyme, because whatever the enzyme is came from the product, that is the intermediate product. So next it get converted to the 1,3 bisphosphoglycerate by using the phosphoglycerate kinase, and also 3-phosphoglycerate and 2-phosphoglycerate. 3-phosphoglycerate is by using the phosphoglycerate mucase. So this is not the kinase. See, phosphoglycerate mucase, and next 2-phosphoglycerate by using the enolase. So sorry for that. This is the enzyme for this step, and this is the enzyme for conversion of 2-phosphoglycerate to the 2-phosphoenol pyruvate. And 2-phosphoenol pyruvate is get converted to the pyruvate by using the pyruvate kinase, and the 2-pyruvate is get converting into the 2 molecules of acetyl-CoA. Here I have to say you that the continuation of glycolysis, we are getting acetyl-CoA, right? So if you have seen what the video posted by me previously before this video, so I have posted citric acid cycle. So citric acid cycle starts from the pyruvate to acetyl-CoA. So acetyl-CoA, by combining with the oxaloacetate, that it get converted to the citrate by using the citrate synthetase. So see, every glycolysis process have the chance to convert into the TCA cycle. So that's why I have saying you again and again. So try to remember, glucose is the starting product of glycolysis, pyruvate is the end product of the glycolysis, and or the acetyl CoA. And here the this continuation of glycolysis entered into the TCA cycle. So that's why first I clearly explained TCA cycle. So if you are interested, so make sure to see that video. And one more thing, just see here, in each cycle of glycolysis means for every single glucose molecule, I am here explaining only for one glucose molecule, not for two. See, for every single glucose molecule there are two glyceraldehydes, two 1,3 phosphoglycerate, and two 3-phosphoglycerate, and two 2-phosphoglycerate, and two phosphoenol pyruvate, and two pyruvate molecules, and two acetyl CoA. Okay, I hope you have understood this clearly. And if you want the structures related to that, so make sure to comment possible. Immediately I will post the video. This is complete information about the glycolysis. So thanks for watching. So here I want to conclude that glycolysis is stimulated by the insulin to reduce the blood glucose levels, and this is useful in the patients of diabetes mellitus, because in diabetes mellitus patients there is the excessive production of glucose in their blood. So we say this as the hyperglycemia or the excessive blood glucose levels in the body. So by using the glycolysis we can control the diabetes mellitus as a one step video. And make sure to subscribe and comment. And thank you so much those who are supporting a lot to this channel. It's really a great thing to me. Thank you so much each and everyone. Thank you. Thanks a lot.